Alright, so I got 4 problems left to do in this video. Let's take a look at the first one. Can you conclude whether the parallelogram is a rhombus, a square, or a rectangle? Explain. So we have parallelogram A, B, C, D. Notice the markings here, right? So let's write down what we are given. So we are given that segment AB is congruent to segment CB, right here. And that angle ABD is congruent to angle CBD. I don't like how they do this, right? They're not staggered enough, right? It should be like here and here, more staggered. Okay. So I think that we have a diagonal, right, of a parallelogram bisecting one angle. So this angle is being bisected. So if we can show that D is also being bisected, then I think we have a rhombus, right? That would, because you have a diagonal bisecting a pair of opposite angles. So let's try to prove, right? Let's try to prove that these two angles are congruent. That's our goal, right? Well, how are we going to do that? Well, I think we can prove these two triangles are congruent, right? So I have a side pair, I have an angle pair. They share side BD, right? By the reflexive property, BD is going to be congruent to itself. There's your second pair of sides. I believe these two triangles are congruent by side, angle, side. So triangle ABD is congruent to triangle CBD by side, angle, side. So now all of its corresponding parts are congruent, and those two angles here at D are corresponding parts. Angle ADB will be congruent to angle CDB by CPCTC. Thus, diagonal BD or segment BD bisects angle ABC and angle ADC, a pair of opposite angles. So parallelogram ABCD is a rhombus. And there you go. That's an exclamation point because I'm so happy it's a rhombus. Okay, so you can see how they're each like little mini proofs, yes? Okay. Next. All right, so same thing. Can we conclude it's a rhombus, square, or rectangle? So in this picture, what am I given? So we are given. So I see the perpendicular diagonals, right? We are given that segment PR is perpendicular to QS. So already I know that this is a rhombus, right? So parallelogram PQRS is a rhombus. And again, that's because the diagonals are perpendicular, right? Good. Okay, and that is noted by the right angle. Okay. But we also see that all of these little segments are congruent, right? Right? We also see that, and because there's no point there, that the 4 segments of the diagonals are congruent. And by segment addition, right? And by segment addition, right, we would know that segment PR is congruent to segment QS. Because if those two segments are congruent to those two segments, if you add them together, you're going to get a bigger congruent segment. So now we also know, so parallelogram PQRS is also a rectangle. Because now the diagonals are congruent. And if you are a rhombus, and if you are a rectangle, then you are a square. Thus, parallelogram PQRS is a square. And again, that's double excited. 2 exclamation points. Can you believe it? Great. Okay, 2 more problems. So that was the more explaining ones. Now I think we have some algebra problems here. All right. Next. Okay, it says quadrilateral STUV is a rhombus. So what are the values of x and y? So we know that in a rhombus that the diagonal bisects a pair of angles. Diagonal bisects angles. So we know that these angles up top are congruent. We know that these angles on bottom are congruent, right? So the ones on bottom both involve x's. So let's just set them equal to each other. 4x plus 3 equals 5x minus 10. Let's subtract the 4x on both sides to get the x's together. 4x's cancel. 3 comes down. 5x minus 4x is 1x. You don't need the 1, though. The minus 10 comes down. Add 10 to both sides. 3 plus 10 is 13. I don't need the 1 in front of the x. X is 13. I'll do the same thing up here with the y's. Again, they're congruent, so set them equal. 65 minus y equals 5y plus 5. I'm going to go ahead and add y because I don't want to subtract and make it more negative. 65 comes down. You're just adding 1y, so 5y plus 1y is 6y plus 5. Now you're going to subtract 5 on both sides. 65 minus 5 is 60, so 60 equals 6y. The 5's cancel. And now to get that 6 gone, we divide. And our value of y is 10. 10. There we go. Basic algebra. And last but not least, another application with not so much algebra. It says a group of friends set up a kickball field with bases 60 feet apart. How can they verify that the field is a square? Right? So if you notice here, right, you have all 4 sides congruent. Right? So already know the kickball field is a rhombus. So we know the field is a rhombus because it's a parallelogram, right? All right, so here it's a parallelogram because the opposite sides are congruent, and it's a rhombus because all sides are congruent. Because it's a parallelogram with 4 congruent sides. Okay. So how are we to verify that it's a square? So to verify that the field is a square, we must show that it is also a rectangle, right? Because a rhombus and a rectangle make a square. So what is the property of a rectangle? Well, it would be the fact that the diagonals must be congruent. Therefore, verify that the diagonals, and that would be the distance from home to second base, which would be this line. So home to second base, and first to third. That'd be this line, first to third, are congruent. There you go. And that's how you would verify that it is a rectangle and then a square. Great. Okay, so thanks for watching these 3 videos. Again, topic 6 is done. Test is coming up soon. All right, thanks for watching.